I am going to discuss about the excitation of a DC generator. The magnetic field required for the operation of a DC generator is produced by electromagnets. This electromagnets carries a field winding which produces required flux when current is passed through it. The field winding is called exciting winding and the current carried by the field winding is called exciting current. Thus, the way of supplying exciting current is called the method of excitation. So, excitation of DC generator can be done by two methods. One is the separately excited DC generator and the second one is the self-excited DC generator. So, in separately excited DC generator, a separate external DC supply is used to provide exciting current through the field winding. Whereas in case of a self-excited generator, if the generator voltage itself is used for exciting the field winding of the same DC generator, it is said to be called as a self-excited DC generator. So if you consider a separately excited DC generator, here from the circuit you can observe that when the field winding is supplied from separate external DC supply, excitation of the field winding will be separate. So it is said to be called as separately excited DC generator. So the field winding of this type of generator has large number of turns of thin wire. So length of such winding is high with less cross-sectional area. So resistance of this winding is high in order to limit the field current. So if you see the circuit, we can see that it is supplying a load demanding a load current of IL at a voltage of Vt, which is said to be called as the terminal voltage. Now Ia, the armature current, is equal to IL, the load current. The internally induced EMF is supplying the voltage of the load, hence terminal voltage is a part of the induced EMF E. But E is not equal to Vt while supplying a load. This is because when armature current Ia flows through the armature winding, due to armature winding resistance Ra, there is a voltage drop across armature winding equal to IaRa volts. The induced EMF has to supply this drop along with the terminal voltage Vt. To keep the IaRa drop to minimum, the resistance Ra is designed to be very small. In addition to this drop, there is some voltage drop at the contacts of the brush, which is said to be called as the brush contact drop. But this drop is negligible, hence generally neglected. So in all, induced EMF has three components. So if you consider the voltage equation of a separately excited generator, you can observe that the induced EMF has three components. One is the terminal voltage, second one is the armature voltage drop, and the third one is the brush contact drop, V brush. So IaRa is the armature voltage drop, Vt is the terminal voltage, V brush is the brush contact drop. So V brush is neglected. So thank you.